So in as base catalyzed nucleophilic addition reactions, a type is Aldol condensation. And which happens with either two aldehydes, two ketones, an aldehyde and a ketone. Now these two may be identical or different. The same is the case with this ketone. Now before we begin, there is one thing to note, is that if this is a carbonyl group, the carbon adjacent to it is alpha hydrogen, alpha carbon, and the hydrogen attached to that carbon are alpha hydrogen. For aldol condensation to occur, there is actually alpha hydrogen required in this reaction, and if choices are given to choose which gives aldol condensation, we have to choose the one which has alpha hydrogen. Now if we see that the general reaction is, we are going to start with an acetaldehyde, and if we see that I have extended this out, which I am going to explain it in the mechanism, this will react with dilute NaOH, which will act as a base, and what we'll have is CH, C double bond OH product, so what we'll have is, this is alpha carbon, and this is the beta carbon, so what we'll have is beta hydroxy butanal, which is the aldol product. Now if we see the mechanism for this reaction, first we take our alpha hydrogen, which is over here. If we write it out like this, it's going to be much more clear. What's going to happen is, this alpha hydrogen is acidic in nature, so this acidic hydrogen will leave the bond and combine with a base. A base is going to attack it, and then water is going to give off. As a result, we will form something like this, which is a carbanion. Now this carbanion will react with another aldehyde, what will happen is, this has greater electronegativity, it has greater tendency to attract this shared pair of electrons, so it will have partial negative and partial positive charge will develop. This will attract to this part, and a bond will form. So let me write it a little bit clear for you, so you guys can actually see what I'm talking about. So what will happen is, this is the part which is attracted to, this is the part we're talking about. So what will happen is, these two will combine and it will form the product that we're talking about. Now we've just rearranged it for you, so it is better to understand. Now as we can tell that this is shifted, it's electron, so it will acquire this. Now this is actually not stable, so what we'll do is, we'll protonate it. So protonation will occur. Now to get a clear understanding, this is a carbon that is over here, and this is the CH2 that we are talking about here, and this is that group, and this is this group, and this portion over here is over here, and this one is here. So what we do is, we will attach a hydrogen over here. We will attach a hydrogen over here on the O negative. So what will happen is a hydroxyl group will form, and then now we can clearly see that this portion is aldehyde and this portion is alcohol. Now if we see that the ald and the ol, the product formed is an aldol, which is, if we start from here, the numbering alpha beta, we can say that it is beta hydroxy. We've got 1, 2, 3, 4 carbons, so butanal. Now if we start out with the aldol condensation, that will happen if I just elongate this portion out like this. What will happen is this hydrogen and this OH will remove, and then we'll have minus H2O, and then a double bond will form, and then we'll have CH3 over here and H and H over here. 1, 2, 3, 4, 1, 2, 3, 4. So that's what we'll have is alpha beta unsaturated aldehyde. Why is it alpha beta unsaturated? Because alpha and beta. It's also called proton aldehyde, and it is also known as, if we start the numbering, so it is 1, 2 butene al. Now this is the aldol condensation explained, and I hope you understand.